The Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers, UIDs, and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built-in sensors to alert the driver when tire pressure is low, or any other natural or man-made object that can be assigned an Internet Protocol IP address and is able to transfer data over a network. Increasingly, organizations in a variety of industries are using IoT to operate more efficiently, better understand customers to deliver enhanced customer service, improve decision making, and increase the value of the business. How does IoT work? An IoT ecosystem consists of web-enabled smart devices that use embedded systems such as processors, sensors, and communication hardware to collect, send, and act on data they acquire from their environments. IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge device, where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes, these devices communicate with other related devices and act on the information they get from one another. The devices do most of the work without human intervention, although people can interact with the devices, for instance, to set them up, give them instructions, or access the data. The connectivity, networking, and communication protocols used with these web-enabled devices largely depend on the specific IoT applications deployed. IoT can also make use of artificial intelligence (AI) and machine learning to aid in making data collecting processes easier and more dynamic. Why is IoT important? The Internet of Things helps people live and work smarter, as well as gain complete control over their lives. In addition to offering smart devices to automate homes, IoT is essential to business. IoT provides businesses with a real-time look into how their systems really work, delivering insights into everything from the performance of machines to supply chain and logistics operations. IoT enables companies to automate processes and reduce labor costs. It also cuts down on waste and improves service delivery, making it less expensive to manufacture and deliver goods, as well as offering transparency into customer transactions. As such, IoT is one of the most important technologies of everyday life, and it will continue to pick up steam as more businesses realize the potential of connected devices to keep them competitive. What are the benefits of IoT to organizations? The Internet of Things offers several benefits to organizations. Some benefits are industry-specific, and some are applicable across multiple industries. Some of the common benefits of IoT enable business to monitor their overall business processes, improve the customer experience, save time and money, enhance employee productivity, integrate and adapt business models, make better business decisions, and generate more revenue. IoT encourages companies to rethink the ways they approach their businesses and gives them the tools to improve their business strategies. Generally, IoT is most abundant in manufacturing, transportation, and utility organizations, making use of sensors and other IoT devices. However, it has also found use cases for organizations within the agriculture, infrastructure, and home automation industries, leading some organizations toward digital transformation. IoT can benefit farmers in agriculture by making their job easier. Sensors can collect data on rainfall, humidity, temperature, and soil content, as well as other factors. They would help automate farming techniques. The ability to monitor operations surrounding infrastructure is also a factor that IoT can help with. Sensors, for example, could be used to monitor events or changes within structural buildings, bridges, and other infrastructure. This brings benefits with it, such as cost saving, saved time, quality of life workflow changes, and paperless workflow. A home automation business can utilize IoT to monitor and manipulate mechanical and electrical systems in a building. On a broader scale, smart cities can help citizens reduce waste and energy consumption. IoT touches every industry, including businesses within healthcare, finance, retail, and manufacturing. What are the pros and cons of IoT? Some of the advantages of IoT include the following: ability to access information from anywhere at any time on any device, improved communication between connected electronic devices, transferring data packets over a connected network saving time and money, and automating tasks helping to improve the quality of a business's services and reducing the need for human intervention. Some disadvantages of IoT include the following: as the number of connected devices increases and more information is shared between devices, the potential that a hacker could steal confidential information also increases. Enterprises may eventually have to deal with massive numbers, maybe even millions of IoT devices, and collecting and managing the data from all those devices will be challenging. If there is a bug in the system, it is likely that every connected device will become corrupted. Since there is no international standard of compatibility for IoT, it is difficult for devices from different manufacturers to communicate with each other. IoT standards and frameworks. There are several emerging IoT standards, including the following: IPv6 over low-power wireless personal area networks. 6LoWPAN is an open standard defined by the Internet Engineering Task Force (IETF). The 6LoWPAN standard enables any low-power radio to communicate to the Internet, including 804.15.4, Bluetooth Low Energy (BLE), and Z-Wave for home automation. ZigBee is a low-power, low-data rate wireless network used mainly in industrial settings. ZigBee is based on the Institute of Electrical and Electronics Engineers IEEE 802.15.4 standard. The ZigBee Alliance created ... the universal language for IoT that enables smart objects to work securely on any network and understand each other. LiteOS is a Unix-like operating system for wireless sensors networks. LiteOS supports smartphones, wearables, intelligent manufacturing applications, smart homes, and Internet of Vehicles. The OS also serves as a smart device development platform. 1M2M is a machine-to-machine service layer that can be embedded in software and hardware to connect devices. The global standardization body 1M2M was created to develop reusable standards to enable IoT applications across different verticals to communicate. Data Distribution Service (DDS) was developed by the Object Management Group (OMG) and is an IoT standard for real-time, scalable, and high-performance M2M communication. Advanced Message Queuing Protocol (AMQP) is an open-source published standard for asynchronous messaging by wire. AMQP enables encrypted and interoperable messaging between organizations and applications. The protocol is used in client-server messaging and in IoT device management. Constrained Application Protocol (COAP) is a protocol designed by the IETF that specifies how low-power, compute-constrained devices can operate in the Internet of Things. Long-Range Wide Area Network (LoRaWAN) is a protocol for wide area networks designed to support huge networks, such as smart cities with millions of low-power devices. IoT frameworks include the following: Amazon Web Services (AWS) IoT is a cloud computing platform for IoT released by Amazon. This framework is designed to enable smart devices to easily connect and securely interact with the AWS cloud and other connected devices. ARM Mbed IoT is a platform to develop apps for IoT based on ARM microcontrollers. The goal of the ARM Mbed IoT platform is to provide a scalable, connected, and secure environment for IoT devices by integrating mbed tools and services. Microsoft's Azure IoT Suite is a platform that consists of a set of services that enables users to interact with and receive data from their IoT devices, as well as perform various operations over data, such as multidimensional analysis, transformation, and aggregation, and visualize those operations in a way that is suitable for business. Google's Brillo View is a platform for the rapid implementation of IoT applications. The platform consists of two main backbones: Brillo, an Android-based operating system for the development of embedded low-power devices, and View, an IoT-oriented communication protocol that serves as the communication language between the device and the cloud. Kelvin is an open-source IoT platform released by Ericsson designed for building and managing distributed applications that enable devices to talk to each other. Kelvin includes a development framework for application developers, as well as a runtime environment for handling the running application.